All right, well, thank you for joining us, everyone. Again, the topic for today's talk is data visualization and modeling in JMP. I'll be using JMP 12 Pro for this demonstration. I'm going to use two case studies, one of them involving a nominal or categorical response credit card marketing. So this is a situation, and I'll go ahead and open up the data, where our response of interest or our target variable is whether an offer for a credit card was accepted or not as a function of some design criteria, the type of reward, the mailer type, and income level, and then some demographic characteristics. So this is example 1. And example 2 has a continuous response. And here this is data from the city of Boston. In fact, I downloaded it from their website. And it is property assessment data for all single-family homes in a variety of neighborhoods in the Boston area. Our primary variable of interest here is the total value for the property, and you see that we have several variables of interest. Some of these are continuous, and recall if you're new to JMP that the blue triangle relates to continuous data, and the red bars are for nominal or categorical variables. Now, some of these have been recoded, so I've done a little bit of cleanup, and I'll talk about some tools for cleaning up data. The original variables are hidden and excluded, and I'll make these data sets available through our academic community. So with these two examples, we're going to talk about some tools for data visualization, and this will be primarily from the perspective of building a predictive model. So we'll talk about columns viewer for summarizing our data, graphing our data one variable at a time, the graph builder, which is the first option in the graph menu, which is a very dynamic and interactive platform for exploring data, some tools for filtering variables and data. JMP also has geographic mapping capabilities, so we'll see how to do that. And most of these graphing options are available under the graph menu, and we'll only touch on the highlights. I'll briefly talk about tools for data preparation, and this is one of the most important things you can do in any modeling effort, is make sure that your data are properly prepared. In JMP 12 we have some new utilities for working with data, for exploring outliers and missing values. We won't spend a lot of time on this, but I want to point these out. There's also a new feature for creating a validation column, some enhanced functionality for recoding data, and we'll talk about how to transform variables. The bulk of the time we'll spend talking about different tools for building predictive models. Fit model is for building least squares regression models or logistic models, and it has a variety of other types of models that are available. Recursive partitioning, this is classification or regression trees, and there are different types of trees available. I'm going to be using JMP 12 Pro, the professional version, and again this is on a Mac, and JMP runs natively on a Mac or Windows machine, so some of the features are only available on the professional version. We'll see how to fit neural network models. And a feature in JMP Pro is Generalized Regression, and this is for fitting non-normal responses. So if you have a non-normal response, you want to fit a model, and it's also for fitting penalized regression methods. There are two features that are available just in JMP Pro that we'll highlight here. Built-in model cross-validation, and this is if you're new to modeling, this is where you hold part of your data out to double-check your model. So we'll see how to do model cross-validation. And there's also a tool for comparing competing models. So if I fit a variety of different types of models, I can use this platform to compare a variety of different validation statistics. So let's go ahead and get started. I'm going to open up this credit card marketing data. This is a journal that I'm using, and the journal just provides easy access to data sets and also notes to keep me on track. Before I do this, I do want to point out, and I'll do it now, that most of what I'm covering, there are resources available. So I'll go right to the bottom here under Resources for Learning at jmp.com/teach. There's interactive help that's available from the help menu. There's a very active JMP user community, and we have an academic community. jmp.com/learn provides step-by-step instructions for performing specific tasks in JMP. There are a nice variety of case studies available and a variety of webcasts available. So keep in mind that some of what I'm covering here today will be covered through different resources available in JMP. And if you're looking for technical help on topics, our help files come in the form of searchable books and searchable help. So we'll start with looking at tools for data visualization. So this data set has 18,000 rows, has 18 columns. In the top corner, in some data tables, if you open data tables that someone else has created, you may see that code has already been saved. JMP does have a programming language, we call it JSL, and you can use this programming language to save output to the data table. So if I were to click on one of these options, it would automatically launch a platform and conduct an analysis. But we'll do most of this from scratch. So if this were the first time I was looking at this data and I want to be able to build a model to predict whether an offer is accepted or not, a starting point, if you have JMP 11 or beyond, is to use the columns viewer. And the columns viewer allows you to produce high-level summaries of all of your variables. So if I click and drag on the variables of interest, I won't select column number, but I'll select everything else. We can show quartiles or percentiles if we'd like. I'll go ahead and select that. And I'll select Show Summary. So this provides a high-level view of all of my variables. I can see how many observations I have. If I'm missing any values, I'll see something under N missing. And these variables are all selectable. I can see that I'm only missing values for these variables at the bottom, the balance columns. For categorical data, I can see the number of categories, and then other summary statistics. Now from here, if I want to be able to launch graphics, I can select the variables I'm interested in, and I'll just select a subset of these, and click Distribution to launch the distribution platform. Now this is the same output that I'd get if I went to Analyze Distribution and selected those variables from here. And in this case, I've set a preference so when I launch the distribution platform, I get a horizontal view rather than the default vertical view. But the distribution platform provides summary statistics, but then it also provides interactive bar charts and histograms that allow us to explore potential bivariate relationships. It also allows us to look at the breakdown of our data. So here I can see that bank accounts, well, I really only have 3 values of bank accounts, and most people only have 1 bank account. Overdraft protection, most of the customers do not have overdraft protection. Number of homes owned, the average household size, and I can see that most people have between 3 or 4 members in the household. And then for things like average balance, I can see if I've got unusually shaped distributions, or highly skewed data, or if I've got any observations that are unusual. So it's really useful to take a look at high-level numeric summaries, but also graphical summaries before initiating any modeling step. So this is the distribution platform. Now, a graphical platform that gives a lot more flexibility in terms of how we graph and what we graph is under the Graph menu, and this is Graph Builder. And there are a lot of other graphical tools here that we won't have an opportunity to discuss. So we'll go to Graph Builder. And Graph Builder produces a palette. So we've got some drop zones for dragging and dropping variables, and then we've got some zones that allow us to break the data down in different ways. So my response variable of interest here is whether the offer was accepted or not. I'll click and drag this to the Y zone, and I haven't released yet. Notice there's a blue border surrounding this field. This is giving me a picture of what it will look like if I did release. And I'm seeing that I've got many more cases where the offer was not accepted, and when you hold your mouse on any bar in JMP, it's going to show you the corresponding value, and not as many that were accepted. And I can break this down by other variables. So for example, if I start with continuous variables and I want to look at offer accepted yes versus no based on average balance, I'll click and drag average balance to the X zone, and by default I get box plots. The icons across the top represent graph types or graph elements that I can add to this graph. And some of them are shaded out. This indicates that these graph types don't make sense for the types of data that I've selected. If I'd like to add the points, I can click and drag to add points back on. If I'd like to connect the means, the line, this icon right here, if I click and drag, in fact, when you hold your mouse on top of any one of these icons, it gives you an indication of what will be provided if you select that icon. So this view is telling us that the average yes versus no for balance, that it doesn't look like there's really any difference there. And what if I had a categorical variable? I'll hit start over. If I had offer accepted against a categorical variable like reward, and this is the type of reward that was offered, we get a view, and we actually need to make a change here to make some sense out of this. When we're dealing with a categorical variable against a second categorical variable, a very useful graph is up here at the top, and it's called a mosaic plot. And what the mosaic plot does is it basically produces two bar charts that are crossed with one another. So we see a breakdown of offer accepted, and then across the bottom we see the breakdown of air miles versus cashback versus points, and then within each one of those categories we see the breakdown of offer accepted. So in air miles we see that the values, that 7.7% of the offers were accepted versus cashback where we only had 3.4% accepted. So this is called a mosaic plot. And we have several different categorical variables. We can click and drag an additional variable to add this to the graph. So here I'm breaking it down by mailer type. I'm looking at letter versus postcard for those same categories. Or I could drag this to a different zone. So if I drag it to the overlay or color, in some cases it's not clear what it's doing, I can drag it to the bottom, and this is building a hierarchy depending on where you put it. So here I've put it on top. It's first sorting by mailer type, and then it's breaking it down by reward. So you can break the data down in a number of different ways. An alternative to this, if you're interested in looking at all of the different variables, and I'll click done here, is to use what we call a columns viewer. A columns viewer is available from every platform, and it's particularly useful when you have a lot of variables. So I'll go all the way down to the bottom under script, and it's called column switcher. And the first thing it's asking is, which variable do you want to be able to switch out? We're most interested in offer accepted, but I want to look at my different predictor variables. So now if I select other predictor variables that are the same type, here's a reward, I'll hold down the control key, mailer type, income level, credit rating. So I'm just selecting all of the categorical variables and click OK. What this is going to allow me to do is toggle between each of these. So for mailer type, if I hold my mouse on top of the green for postcard, I can see that 7.9% of those offers were accepted. For income level, it looks like the low income levels we had more accepted. For credit rating, low credit rating. Overdraft protection is very flat. Own your own home is also very flat. So if you've got a lot of different variables, this allows you to recreate that same graph for all the different variables. Now I'll put this back on, say, income level, and let me remove the column switcher. And a second tool that's very useful for interacting within a graphic is called the data filter. There's a local version of the data filter under script right above the column switcher. And what this allows us to do is update a graph or analysis based on values of another column. So I'm looking at offer accepted versus income level, but if I want to update this based on, for example, credit rating, I'll select credit rating, and now if I toggle through the different credit ratings, then it's only graphing based on the selected credit rating. So I can see that if I've got a low credit rating and a low income level, that roughly 16% of the offers were accepted. So here I'm looking at two variables at the same time, and it looks like there's some sort of an interaction going on here. Let's take a look at the other data set, which is continuous data. So here I've got 26,000 observations where I've got a continuous response. Well, I can use the same tools for continuous responses. In fact, I have more options when I have continuous responses. Here, for example, if I want to look at total value versus, for example, building value, we can see that there's a very, very strong linear relationship between these two variables. How about the different predictors? So I can do the same thing with the column switcher and switch out all of these different variables, or I could drag them one at a time. For example, lot square footage versus total value, it appears that some properties, the value doesn't depend on the square footage of the lot, while others it looks like there's a linear relationship. And you can learn a lot about your data and potential relationships by using these interactive graphics. One quick tool I'll show from here is that this graph builder and other platforms in JMP also have the ability to plot images or to do geographic mapping. So for example, if I take latitude and longitude and drag and drop, JMP recognizes them appropriately, and we've got each observation that's placed according to the latitude and longitude. I'll get rid of this smoother, and since I know I have geographic data, if I right-click in the middle of the graph and go to Graph and go to Background Map, JMP has a street map service, and if I select this and click OK, then we're able to see the streets in Boston. So this is all single-family homes in Boston for 2014. I'll make it a little bit bigger here. I can use this magnifier to zoom in. I can see the different neighborhoods. And let's add a little bit more information to this. So for example, I'm really interested in the different neighborhoods. I'll grab neighborhood and drag it as a color variable. We can use variables as size variables. We can lay things one on top of another. Now I'll use my hand tool to drag this around, and notice that each of the neighborhoods is color-coded. And then I generally fly out of the Boston Logan Airport, and we can see that homes in that area are in East Boston. So if I'm interested in building a predictive model for property values in East Boston, I know that all these homes fall in this general relative area. And since I've got all of this data and I want to focus in on East Boston, I mentioned earlier that there is a local data filter, and the local data filter will only interface with the graph or analysis that we have open. There's a global data filter under the rows menu, and this is simply called data filter. And from this point forward, I'm going to only analyze data from East Boston. So I'll select neighborhood and then East Boston. And this has selected those observations. There's 757 homes. And I'll click show. And in the background, what's happening is the JMP is hiding all of the other observations. And I'll click include. And this is redoing any analysis without those other observations. So from this point forward, the only observations that will be included in analysis are from East Boston. So let me close these out. Other tools available, if you're interested in looking at several different pairwise correlations, you can do this graphically or numerically through the multivariate platform and also through scatterplot matrix or scatterplot 3D. So let's move on to tools for data preparation, and we're going to do this relatively quickly, but this is one of the most critical components of predictive modeling. So some of the tools I'll point out, transformations. I'll go back to this property assessment data, and let's take one of these variables. So for example, I'll plot a distribution of the total value. And we can see that the total value is highly skewed. Now, if we decided that we needed to be able to do a transformation of this variable for future analyses, from the data table, if we right-click and select New Formula, there's an option to transform. And a lot of the popular transformations are here. So if I click Log, automatically I get a new column in the data table. And if I right-click on this column, you'll see that the formula is checked. So JMP has written a formula for this, and the formula is the log of the total value. And if we did this manually, the option would be from the transcendental function. Now you can also do this from your graphing platforms. So for example, if we were in the graph builder and we wanted to be able to transform total value, I'll click and drag and I'll ask for a histogram. So here's a histogram of total value. In fact, let me drag it to the bottom and ask for a histogram. And we can see that it's skewed. I'll use my grabber tool to change the binning. Now if I wanted to transform from here, and this is a really nice place to transform data if it's necessary, if you right-click on that variable, those same transformations are available. And if you're dealing with date data, you'll see transformations for dates. So this will update based on the type of data you're looking at. I'll select that same transformation, and this gives me a chance to try it out. So I'll drag log total value across the bottom. And again, I'll use my grabber tool, and I can see my data is now far more normal. And then if I right-click on this, I can ask for JMP to save it to the data table. Now, other types of data preparation tools that might be important. Recode. If you're dealing with categorical data, and this data set has a lot of categorical variables, for example, the building style, the roof type, the exterior finish. In fact, I'll select these. Under columns, you'll see all of the utilities. Under utilities, and if you have JMP Pro, you'll see modeling utilities. And the very first option is Recode. And this was moved in previous versions of JMP. It was simply listed on the columns menu. But there are a lot of different features here. I use this a lot if I've got missing values that I'd like to recode, or if I've got some levels that only have 1 or 2 observations that I'd like to combine, or I use it if I've got data quality issues. So if I click on the red triangle, you'll see that there are a lot of options. JMP is case sensitive, so I may want to convert to title case or upper or lower case, trim out some white space, or I might want to group similar values. So there are a lot of options for cleaning up data, and for whatever changes we make, there are different options for where we put this cleaned up data. And the recommendation is to put the data in a formula column that stores the logic for whatever cleanup work you've done. Now, a few other options here that I'll simply point out under columns, modeling utilities, some new features for exploring outliers, for exploring missing values. A make validation column is a new feature. If you're building predictive models, validation gives you a way of honestly assessing how good that model is. And generally what we do is we take the data and we split it into different sets. The training set is what is used to build the model. The validation set is used to check the model. And then the test set gives us that last final assessment of how good the model is. By default, you'll see 75% of the data will go into training set and 25% will go into the validation set, but you can change these numbers as needed. And you can also specify whether you want the data partitioned purely at random or using a stratified random sample. And if you've got unbalanced data, so your percentages in the target groups are not equal, then stratified random is preferred. Let's now go into the predictive modeling tools. And I'll start with this property assessment data. Fit model is used for ordinary least squares regression if you've got a continuous response, and there are a lot of other features that are available directly from this platform. So for example, we can do stepwise regression for model selection. There's a really nice tool for visualizing a model called a prediction profiler. This platform is integrated with SAS, so you can use this to write SAS code, and if you're connected to SAS on your machine, you can use this to run the code in the background in SAS and to bring the results right back into the JMP. So we'll keep this simple and we will simply build a model, and fit model is under the Analyze menu, fit model. And I'll build a model to predict total value as a function of 17 predictors, and here I've already cleaned up the data. I'll click Add. A feature under the red triangle that I'll point out is informative missing. If you're missing values, what informative missing will do is create a new column indicating whether the value is missing or not, and I'll impute the mean where the values are indeed missing. And I'll start without a validation column and simply click Run. First thing you'll see is what we call an effects summary table, and this is new in JMP 12. And this provides a high-level summary of the significance of the terms in the model, and it also provides an easy way of reducing the model. So in previous versions, you had to go up under the red triangle and go back to that model dialog window to reduce the model. Instead, if you determine that certain terms need to be removed, if you select those terms, and here I've selected kitchen, which has a high p-value, you can click Remove. Or if you determine that certain terms are missing from the model, like a quadratic or an interaction, you can click Edit and add terms to the model. By default, you're going to see a summary fit table, an analysis of variance table for the whole model fit, and you'll also see the parameter estimates. And notice that where you've got categorical variables, you'll see a parameter estimate for each one of those, and JMP holds out the highest level. So you'll see k-1 parameter estimates for a categorical variable. And at the bottom, you'll see an effects test. Some of the options are the red triangle, and if you're relatively new to JMP, keep in mind that we hide additional options under the red triangle. We try to give you the default statistics that we think you're most interested in, but there's always additional options available. So for example, if I'd like to be able to look at my prediction model that I've just built, I can ask for the prediction expression. JMP uses a coding for categorical variables, two-level categorical variables, -1, +1, rather than the typical dummy coding. So if you'd like to see the same coding scheme for the parameter estimates that's used by SAS and many other programs, then select indicator parameterization estimates. Under factor profiling are some nice graphical tools. Diagnostics provides residual plots and some other information. If you're doing model diagnostics, so for example, you're looking at influential values or the studentized residuals, any one of these options will save a new column out to the data table. So for example, if I select prediction formula, back in my data table, I've got a new column now, and it's at the very end of the list, and anywhere you see a plus in JMP is an indication that I've got a stored formula. So I've just saved out that linear formula, and you can take a look at it here. So if I were to add a new row and enter values, it would make a prediction for me automatically. Now, a really nice tool for exploring this model is under factor profiling, and it's called Profiler. And what the Profiler does is it takes the model we've built and allows us to interact with that model. The slope of the line corresponds to the coefficient. The steeper the slope, the larger the coefficient. If it increases, the coefficient is positive. If it decreases, it's negative. And as I click and drag, I can see what happens to the predictive response, and I also get a confidence interval for that response. If I've got interactions, I'll see the slopes of those lines involved in the interactions flip as I drag from one level to another. And a couple of other tools available here that we don't have time to go into. There's a Monte Carlo simulator available, and there's also this nice tool that I'll show very quickly called Assess Variable Importance. And this does the simulation where it tries to assess which of the variables out of all of the variables involved are the most important. And then it gives us these marginal model plots. So basically what we're looking at here is for the lot square footage, I'm controlling for all of the other variables, so I'm isolating out the effect of this one variable on the response. And it sorts these in descending order of importance. And this is available only in JMP Pro, and again it's called Assess Variable Importance. So this is ordinary least squares regression, and I'm going to go back to the model dialog window, and let's see what happens if I've got validation. Well, if I've got validation and click run, then JMP is holding out some of my data. In this case, it's building a model on 454 observations that are in my training set, and as I scroll down, we'll see that there are also validation statistics. So it's building the model only using 454 observations, but then it's checking how good that model is using this validation set. And we can see the R-squares are actually pretty comparable. RASE, the root adjusted squared error, we generally expect that to be a little bit higher for the validation set. The reason we use cross-validation is to make sure we're not overfitting our model. So we want to make sure that we're explaining structure in the data rather than simply noise. And if these values are very similar, it's an indication that the model is doing a pretty good job modeling structure. So let me go back to the model dialog window. And a tool for reducing this model is under the personality, and it's called Stepwise. And Stepwise is available for either continuous responses or for categorical responses. So I'll click Run. And if we scroll down through the list, you notice that we have an interesting coding scheme for categorical variables. And to make sure that JMP is only considering each categorical variable as a whole effect, under Rules, I'm going to select this option, Whole Effects. So we're not going to dig into how JMP parameterizes. But by default, the stopping rule here is max validation R squared. So this is an automated procedure where if we click the Go button, JMP will build a model, and it'll stop when it finds a model that has a maximum value for the validation R squared statistic. So I'll hit Go, and it's searching through all the terms, and the model that has the best validation statistic has lot square footage, year built, building style fell out of the model, roof type is important, exterior finish is important, so we see a lot of different variables that show up. Under the stopping rule, there are different stopping rules available, so if we're not using a validation set, AIC and BIC can be used. And if I click Make Model or Run Model, then this will actually launch that model. So it's a nice automated tool for model reduction. So let's switch gears now and talk about different types of models. So I've been focusing on least squares regression. What is recursive partitioning? Well, if I've got a categorical response, we call this classification trees. And if we've got a continuous response, it's called the regression tree. And I'll use this same data. And partition is found under the modeling platform. We specify what the response is. Here the response is total value and the predictors. Again, there's an option to use validation. And if you're building predictive models, then validation is very important. Types of models that are built here, by default, you're going to see a decision tree. So JMP is going to do a series of binary splits in the data to be able to predict the response. And some other options that we'll come back to are bootstrap forests and boosted tree, and new in JMP 12 is this feature k nearest neighbor. So I'll click OK. The solid line is drawn at our overall mean. And what JMP is going to try to do here is it's going to search through all of the variables, and we're calling those variables candidates. And it's going to search through all of those and try to find the variable that pushes the mean as far apart as possible. It's going to do one split, so it'll be two nodes or two branches, and it's trying to find the variable and also a cut point for that variable that causes two means to be as far apart as possible. So if I hit split here, JMP is telling us if the lot square footage is less than 3450, then the average home price is $203,000. If it's greater than or equal to that, then the average home price is $314,000. So there's a big difference between these. As I do this, it's keeping track of some statistics for us. Now the next split will be based on whichever candidate in each one of the nodes drives the furthest separation. And it's using this log worst statistic, which is related to a p-value. And whichever one has the highest log worst statistic, in this case we see that it's on this side and it's the year built, that's going to be the next position that JMP splits. So I'll hit split. So now we've just built a series of if-then statements. If lot square footage is less than 3450 and the year built is before 1991, then here's the average home value. If it's greater than 1991, then this is the average home value. And we see that we only have 9 observations in this node. If we click go, what JMP is going to do, since we have a validation column, is it's going to keep splitting until it can't split anymore. And in this case, what it's going to do is it's going to drop back. It's going to find the point where we have the maximum validation R-square. And it'll continue to split 10 more times after that. And then the optimal model is where we have the maximum validation R-square. So here it's saying the maximum model, or the best model, has 18 splits, and here's the R-square and then the root mean square error. Now some tools for visualizing this model under the red triangle. One tool is called column contributions. And what this does is it summarizes all of the variables that are involved in the splits. So we see lot square footage, again, shows up to be really important. Living area, year built, and then we've got some down here that weren't involved in the splits at all. Now under the red triangle, any model we build can be saved out as a formula. So we can save the prediction formula and we can compare this model to a previous model we fit. So this is classic decision tree when we built a regression tree. Let's close this and take a look at some of the other tree models. I'll go back to partition, I'll hit recall, and instead of a decision tree, 2 other options that we'll talk about. One of them is a bootstrap forest. Now what this is going to do, and I'll go ahead and hit OK, is this is going to build a bunch of little trees. So we're going to build a forest, and each forest, in this case I've got 100 trees in the forest. In each forest I'm randomly sampling my variables. I'm also random sampling from my data, and my predicted response is going to be an average of the predictions from all of these different trees. So I'm building a whole bunch of little trees and I'm averaging them together. And the value of doing this is that in a classic regression tree or a classification tree, what happens is the first split defines all future splits. So there are some variables that never get a chance to enter into the model. So this allows those other variables a chance to be involved in the model. So I'll click OK here, and JMP hides the trees that have actually been built and produces the summary statistics. But what we've done is we've built a bunch of trees. The first tree had 11 splits, the second tree had 3 splits, and the trees themselves are under the red triangle, where we can ask for show trees, and I'll just select show names. Now this forest only has 14 trees, and this is what the first tree looks like. The second tree only has 1. Here's the third. And the final predicted model is going to be an average of each of these. And generally this type of modeling does a very, very good job of explaining the response. Again, we could look at column contributions, and we see that there are more terms now that have entered into the model. But we see the same basic terms dominating. Now the last type of tree method available, again under partition, and I'll hit recall, is called boosted tree. And what a boosted tree is going to do is it's going to build a tree, and then it's going to calculate the variation left over after we fit that tree, and it's going to fit a new tree on top of those standardized residuals. And then it's going to keep doing that. So a layer is it's each time I build a model on top of the residuals from the previous model. So what it's essentially trying to do is explain all of the variation. So I'll click OK. And we see similar output. In this case, the R square is quite a bit higher. And again, we can look at the trees. So we've got several little trees that are involved. And there are controls for specifying the number of trees and the number of layers. But this generally is a very good method for modeling. And let's take a look at the column contributions. Again, lot square footage was the biggest, shows up repeatedly. And in this case, we're seeing similar variables that show up in the modeling. And the last type of model that I'll introduce is under modeling, and this is called neural nets. And I'll go ahead and fit this, and then we'll talk about it. So my response, same response, and I'll select all of the factors again. Most of these platforms have the ability to handle missing data. It's selected by default in partition, and I'll go ahead and turn it on here. And again, I'll enter a validation and click OK. Now this is neural networks in JMP Pro, and what we're going to do is we're going to build a highly nonlinear model. In JMP Pro, we've got 2 layers that we can build in this model. In JMP, we only have 1, and there are 3 different activation functions. So essentially, our final model is going to be a linear combination of some nonlinear models, and the type of model that's involved is based on whatever we select here. Tan H is logistic regression, linear, and then Gaussian is like the normal distribution. I'll go ahead and just click Go here. And there are a lot of options here, and we see some nice summary statistics. This generally fits the data extremely well, but tends to be somewhat of a black box. So our model that we've just built, and let me go out and find the dialog, looks like this. So we've got all these terms in the model, and then we've got, in this case, we've got 1 hidden layer with 3 nodes, and in each one of these we have this nonlinear function. And the final predicted value is a combination, a linear combination of these 3 functions. And if I save this formula out to the data table, you'll see that the model gives you the formula for the 3 hidden layers, and the final prediction is the sum of what's produced from these hidden layers. So let's actually go ahead and add these since I've done this in the past. Let me go ahead and do this. Alright, so these are the new formulas that show up. So I've got a hidden layer, another hidden layer, another hidden layer, and here's a prediction formula. And the prediction formula is just a linear combination of those 3 hidden layers. If we look at each one of those hidden layers, in fact, I'll just right-click here and select Formula. Here's the formula for the hidden layer, and you can see that it uses the tan H function. And let me go ahead and just delete these out of there. Okay, so that's neural networks. One more tool I'll introduce while we're here, and this is only available in JMP Pro, and this is in Fit Model. And I'm going to go ahead and build the same model I built last time. But instead of using the personality stepwise to reduce the model, or using standard least squares regression, there's this new platform called Generalized Regression. And what this allows us to do is specify the response distribution. In this case, we've got continuous data, and we assume that normal's okay. And there are different options for fitting models here. The default is lasso, and these last three are penalized regression methods. And these are particularly useful if you've got highly correlated x's. So for example, if I look at this data and I go out and I create bivariate correlations and I take a look at some of the continuous variables, I can see that some of these are correlated with one another. Make this a little bit wider here. So gross area and living area are correlated. Living area and the number of rooms are correlated, and the numbers are shown up above. So here's the correlation between living area and gross area. And what this can cause when you fit a model is for your parameter estimates to be inflated. So what these penalized methods do is they apply a shrinkage or penalty to shrink the size of the parameter estimates. Lasso and elastic net are also used for model selection. So the shrinkage can cause parameter estimates to become 0, which allows you to reduce the model. Maximum likelihood here will fit similar parameter estimates to least squares regression, and forward selection is an alternative to the stepwise selection platform that I showed earlier. So what I'm going to do for now is just run one of these and just consider this to be a brief introduction. I'll click go and go ahead and maximize this. So what JMP has done is it's fit a model, and I'm going to drag this over. And this is the new feature in JMP 12 where you can change this. We call this a solution path. And when we first fit the model, if every single term is in the model, these are the parameter estimates for the terms in the model. And we center and scale the parameter estimates. And we can see that some of these estimates are relatively large. When we apply a penalty, and I'll just drag this, we're applying a penalty. And what we're trying to do is we're trying to shrink those parameter estimates. And at this point here, wherever that dashed line is, this is what JMP finds this is the optimal model. And at that point, we see that some of the parameter estimates are now 0. In fact, quite a few of them. And as we keep going, we see that it continues to drop terms out of the model. So in this case, I've got a validation set, and it's using the scaled log likelihood, and it's finding the model that gives us the minimum log likelihood for the validation set. And there are different types of models we can build here, and there are also different validation methods that we can use. But all of them are interactive. The final model that's produced will look a lot like an ordinary least squares regression model, but this helps us to sort through where we've got highly correlated predictors. So it's a nice alternative to using stepwise regression. Now I've built a whole bunch of models before we got started, and I've saved the prediction formulas for all those models. A very nice tool for comparing those models under Analyze, Modeling, is called Model Comparison. And again, this feature is only available in JMP Pro. And what Model Comparison does is it takes those stored formulas, and I've got a bunch of them here. You don't actually need to tell JMP what those formulas are, it'll recognize them, but I'm going to put validation here as by. And what I'd like to do is I'd like to compare these models based on their validation statistics. So I'll click OK. And under training, we see the statistics, and these are for the models built on the training data. And this is what we're most interested in. So this is based on the validation data. And in a real-life modeling situation, we would most likely have a third set, which is the test set. And the reason we'd have a test set is the test set is not used in building the models or in model selection. So it gives us a really good, honest assessment of how good the model is. So the 5 types of models I've built a fit least squares regression model using stepwise. I've fit a lasso model, an elastic net model. So both of these were from generalized regression, and both of them used a penalty to help us select the terms in the model. I built a bootstrap forest, and I built a neural model. And the summary statistics down below, we see an R-square, the RASE, the root adjusted squared error, average absolute error. And notice that these first 3 models are actually pretty similar. Neural network, which is considered a black box, if this were similar to the others, and it's actually pretty close, we would tend to opt for a model that's a little bit more interpretable. In fact, all three of these models are pretty comparable, and the form of the equation that you get is going to look very similar. So that's model comparison. Now let's take a look at the same thing when we're dealing with a categorical response. So here we've got credit card marketing, and I'll minimize some of this stuff. And here, if I fit a model, I'll use offer accepted. I'll select all of the terms in the model. Note that by default, JMP switches the personality to nominal logistic. Again, I'll use a validation set, and I'll click Run. Again, we see this effects summary table. And where we see a dot, JMP is telling us that it doesn't have the information it needs to be able to estimate that term. In fact, when we look down through the list, it shows it as being zeroed. And this is an indication that we just don't have enough information to be able to estimate that. In fact, it's biasing these other terms. And it's probably because the average is based on these four values. So it's a hint that we need to remove something. If I click on this and hit remove, that problem goes away. So if I look down below, notice that now I don't see that bias here. Now if I continue to reduce these, in general I'll remove them one at a time, but here I'll just expedite the process a little bit. We can eliminate the non-significant terms, and it looks very similar to what we did with least squares regression. We get some nice summary statistics, so we get information for the training and the validation set. We get the parameter estimates for the terms in the model. And again, in the red triangle, we can see the profiler. And the profiler allows us to change the values of the x's to see the predicted response. It also allows us to see interactions, if we had interactions in the model. Other things you'll see for categorical data, you'll see the ROC curve. And the focus here would be on the ROC curve for the validation data and the area under the curve. You'll see a lift curve. And the lift curve is how many times better the model is at predicting than just chance alone. And we'll see a confusion matrix. So this gives us a breakdown of the false positives and the false negatives. Same thing for other types of models. If I were to build a partition model, the setup is exactly the same. So again, I can do offer accepted. I'll select all of the x's. Since I've got a categorical response, JMP is now going to do a classification tree rather than a regression tree. And the same options are available on the side. Again, I'll select validation here and click OK. And in this case, what JMP is doing is providing the breakdown of yeses versus no. There are a lot of options available in the red triangle. I typically modify this before I get started. So for example, I'll show the split count. And what that does is down below it shows me the breakdown of yeses and nos and the probabilities. I'll also turn off the points. That cleans it up a little bit. And if you're letting JMP build the model for you, you may choose to turn off the tree or turn off the graph, and this will just clean up your display. Since I've got a validation column here, if I click Go, then JMP automatically does all of the splits for us. And the optimal validation R-square is at 9 splits. And the key variables that show up as being important are the credit rating, the mailer type, the reward, and the income level. In fact, if we prune this guy back, we can see this pretty clearly if I do my first split. The first split is on credit rating. So if the person has a low credit rating, the probability that they accept is 0.1, but if they're medium or high, it's 0.3. And if I split again, credit rating low, postcard, almost 15%. And one more split here. And the least optimal situation so far is if a person has a medium or high credit rating and the offer is cashback. Only 1% of those customers accepted the offer. And again, we can continue to build models. We can use lasso, so under fit model. In this case, we can use generalized regression and change the response distribution to binomial. And lasso and the penalized methods are available Neural networks also available. So the same modeling types are available whether you've got a categorical response or a continuous response. In this case, have I saved any models? I haven't saved any models, but we can also use the same tool under model comparison to help us identify what the best prediction model is. So what have we talked about today? We actually jumped through quite a bit. We saw 2 examples. For data visualization tools, some tools that are really useful anytime you're just getting started with data. Under columns, the columns viewer for looking at a high-level summary of your data. Under Analyze the Distribution platform, one of my favorite platforms for looking at variables one at a time. You're trying to understand the shape of the distribution, the centering, and the spread of the distribution. It also points out if you've got any potential data quality issues. Graph Builder for dynamically graphing your data. And the local data filter and column switcher allow you to explore different columns or values of a particular column. The data filter, I do want to distinguish under rows. This data filter under rows interfaces with the data table itself, whereas the local data filter only interfaces with the graph that you currently have open. So there's a difference between those two. If you've got latitude and longitude, you can create geographic maps, but you can also create maps if you've got shapefiles, and JMP comes with some shapefiles installed. And there are a variety of different tools for exploring potential correlations between variables. We talked about some tools for data preparation, and we really skimmed over this. Keep in mind that a dynamic transformation, if you right-click on any column in the data table, there are transformation options available. I generally do that within the Graph Builder platform, so I can explore that transformation. Utilities Recode, this is for cleaning up data quality issues, particularly with categorical data. And some new platforms for exploring missing values, exploring outliers. I didn't actually talk about this last option, predictor screening. If you've got a very, very large data set, and before you start modeling, you want to whittle that down to just the most important variables, predictor screening is extremely useful for that. And it actually uses a Bootstrap forest to do this. So it goes through and it does the random sampling of variables and data and returns back those variables that are most important. Now for predictive modeling, we saw that the Fit Model platform is used for ordinary least squares regression or stepwise regression or logistic regression, and there's some really nice tools built in. Recursive partition, which is classification and regression trees, also has some advanced functionality. Neural networks, which in JMP only has 1 hidden layer and 1 activation function, and JMP Pro has 3 functions and 2 layers. We didn't talk about boosting, but boosting is also available in neural networks. And then in JMP Pro, Generalized Regression, which provides some nice penalized methods for building models.